This video describes two new acceptance sampling plans for attributes added to Statgraphics Centurion version 17. They're based on Military Standard 1916 and the ANSI Z1.4 standard. Acceptance sampling is used to verify that a lot or batch containing capital N items has an acceptably small percentage of unacceptable or non-conforming items. In a typical acceptance sampling plan, lowercase n items are randomly selected from the lot and inspected. If the number of non-conforming items in the sample is less than or equal to an acceptance number C, then the lot is accepted as is and no further inspection is performed. If the number of non-conforming items exceeds C, the lot is either rejected or subjected to 100% inspection. Statgraphics Centurion contains various types of acceptance sampling plans for dealing with attribute data. It contains OC, AOQL, and LTPD plans, which are plans based on consumer and producers' risks at specified levels of percent non-conforming items. It also contains Military Standard 105E, also known as ANSI Z1.4 and ISO 2859. This standard was adopted by the United States Department of Defense in 1989 based upon work done by Schuhart, Romick, and Dodge. Also in version 17 is Military Standard 1916. This is a standard adopted by the U.S. DoD in 1996. It generates C equals 0 acceptance plans. When creating a sampling plan using Military Standard 105E, ANSI Z1.4, the following items need to be specified on the data input dialog box. First, you need to choose the attribute. Will you be counting the proportion of non-conforming items or quantifying the rate of nonconformities per unit? These two attributes are usually characterized by binomial and Poisson distributions, respectively. Secondly, you need to specify the range containing your lot size, capital N. You also need to pick an inspection level, which is normally set by contract. There are 3 inspection levels you can choose from, with inspection level 2 being the default. The fourth item to be selected is the AQL. This is the desired average quality level, or the maximum percent or rate of non-conforming items that is acceptable. There are 3 types of inspection: normal inspection, reduced inspection, and tightened inspection. When sampling begins, normal inspection is typically used. If the quality turns out to be quite good, then reduced inspection might be implemented, or if the quality turns out to be worse than expected, tightened inspection can be implemented. Finally, you may select either a single, double, or multiple sampling plan. As an example, let's suppose I have a lot containing 2,000 items. I want to be sure that the average proportion of non-conforming items in the lot is no more than 0.5%. What plans are available? To find out, I've loaded Statgraphics Centurion version 17. I'll go to the main menu and select SPC. I'll then select Acceptance Sampling, Attributes, Military Standard 105E. On the dialog box, I'll set the attribute to percent non-conforming. I'll pick the lot size containing 2,000. Inspection level 2 is the default, so I'll go with that. There are a selected number of AQLs I can pick. I was looking for 0.5%, Z1.4% is close. We'll start with normal inspection, and I'll accept a single sampling plan. When I press OK, I'll see a list of tables and graphs. I'll take the defaults, and it'll open up an analysis window. If you double-click on the analysis summary, you'll see the sampling plan that was created. It says I should take a sample of 125 randomly selected items from my lot. If I see one or less non-conforming items, I should accept the lot. Two or more non-conforming items will lead me to reject the lot. I can also look at the graph in the upper right corner of the analysis window. This shows the operating characteristic, or OC curve. The operating characteristic curve plots the probability of accepting a lot as a function of the percent of non-conforming items in the lot. You can see, for example, if there were 1% non-conforming items, there's about a 0.6 probability that I will accept that lot using this sampling plan. I can sometimes decrease the number of items I need to inspect by using a double or multiple sampling plan. I'll go back to the data input dialog box where I initially made my selections, and instead of choosing single for the sampling plan, I'll ask for a double sampling plan. I'll then press OK and look back at the analysis summary to see what sort of plan it offers me. The double sampling plan is a two-stage plan. You start by randomly sampling 80 items from the lot. If you see 0 non-conforming items in that sample, you accept the lot. If you see 2 or more non-conforming items, you reject the lot. Otherwise, if you see 1 non-conforming item, you need to go and take a second sample, also of size 80. In the combined sample of 160, you then accept the lot if there are 1 or less non-conforming items, and reject the lot if there are 2 or more non-conforming items. For a double or multiple sampling plan, we need to look at another chart to see what the average sampling size is. In the bottom right corner of the analysis window, you see an average sample number, or ASN curve. This shows me, on average, how many samples need to be taken to make a decision about accepting or rejecting the lot with this double sampling plan. You can see that the average sample size varies somewhat depending upon the true percentage of non-conforming items. But in every case, the average sample size is less than the sample size required by the single sampling plan. To check out the multiple sampling plan, I'll go back to the data input dialog box once more and set the sampling plan field to multiple. A multiple sampling plan consists of several stages, in this case 7 different stages. At each stage, I'll randomly select 32 items from the lot. After I look at the first 32, I won't be allowed to accept the lot, but if I see 2 or more non-conforming items, I'll be able to reject it. This permits a very quick decision if the lot is much worse than expected. After the second stage, I look at the 64 items that I've taken. I still can't accept the lot, but if I see 2 or more non-conforming items, I can reject it. The third stage takes a third sample of 32 items for a total of 96. At this point, if there were no defective items, no non-conforming items, I could accept the lot. If there were 2 or more non-conforming items, I would reject the lot. It goes 7 stages. By the time I've finished the 7th stage, I've looked at 224 items, and now one decision or another will be made. Version 17 can also generate sampling plans using the newer Military Standard 1916. Military Standard 1916 always generates C=0 acceptance plans, meaning that the acceptance number is always 0 for the number of non-conforming items. The acceptance sampling dialog box requires 3 fields to be set. The first field is the lot size. The second field is the verification level. This is set by contract, similar to the inspection level in the ANSI Z1.4 standard. And finally, there are 3 types of inspection: normal, reduced, and tightened. The Military Standard 1916 procedure generates 2 types of plans. The first is a fixed sample size plan, similar to what we've generated before, in which we sample n randomly selected items from the lot and accept the lot if the number of non-conforming items is equal to 0. The second type of plan is a continuous sampling plan. It consists of 2 phases. The first phase is the screening phase. In this phase, I inspect each item as it is produced. For the first N1 items, all items must conform to the specifications. If I see no non-conforming items after sampling N1, I then go into a sampling phase and inspect only 1 out of every M. To see how this works, let's go back to Statgraphics. I'll select SPC from the top menu, Acceptance Sampling, Attributes, Military Standard 1916. The lot size is 2,000, so I'll pick the appropriate range. There are 7 verification levels. The default level is level 4. And there are 3 types of inspections. I'll start with normal inspection. When I press OK, a new analysis window opens showing me both of the plans that are available. Looking at the analysis summary, you can see that the fixed size sampling plan says I should take a sample of 128 items, accept the lot if there are 0 non-conforming items, reject it if there are 1 or more. This is a little bit tougher than the sampling plan generated by the ANSI Z1.4 standard. You can also see, if you look at the operating characteristic curve, that now there's only about a 20% chance of accepting a lot that has 1% defective items. The continuous sampling plan is shown here. In the screening phase, I inspect the first 572 items produced. If all of those are good items, then I can move to the sampling phase and inspect only 1 out of every 24 items produced from then on. Determining how many items need to be inspected before a lot or batch is accepted is a very important problem.